When we talked about uh, right triangles and talked about solving triangles, we said you needed 3 pieces of information in order to find all 6. I mean, we've got 6 pieces of information, 3 angles, 3 lengths. And with right triangles, we only needed 2 more than the fact that it was a right triangle. Right triangle was was one of our pieces of information. We no longer have that. So we no longer have the assumption that we know it's a right triangle, which means we do need 3 pieces of information. The 3 angles, A, B, and C, the 3 sides, A, B, and C. Now there are lots of different ways we can be given this information, and the way we're given that information is going to determine both how we solve for it and the possible complications that we might have. So let's start off by looking at a couple of cases. Angle, angle, side. So an angle, angle, side would be you're given 2 angles that are next to each other, and you're given a side that goes with one of those angles. So in this case, we might say that the bottom left angle is capital B, and the side with it is little b, and the angle between the two is capital A. In this case, since we know a side that's opposite an angle, I mean, that's the relationship we need for the law of sines. We need to be able to say, okay, here's a ratio of sine of an angle to the side opposite it. And since we have that in this angle, angle, side case, we're able to use the law of sines for that. Similarly, if we have angle, side, angle, in other words, we have a side and we have the 2 angles on either side of it, and that's going to be like A little b capital C, or big B little a C. We've got capital letters on both sides of it with the side that doesn't match either one of them. Now I said we needed a side and an angle, but with this ASA we're able to quickly figure out what that third angle is because it's a 180-degree triangle, right? So we just do a little subtraction and we come up with the angle on the opposite side. So in both of these cases we will use the law of sines. Another 2 options. We might have a side, angle, side. For example, B, C, and the angle between them. Or A, C, and the angle between them. Again, this is going to be a case where you have 3 different letters. We do not have a side corresponding to the angle, and we also don't have a way of coming up with it. So that's one case that we can't use the law of sines for. Another case we can't use the law of sines for is the side, side, side. We don't have any angles, so we're going to have to come up with another law. We'll do that for next time. That's going to be the law of cosines. So that's 4. There are 6 possibilities. Let's look at the last 2. Next to last, angle, angle, angle. We cannot solve these. We've got to have at least one length to know the scale. And just as an example, I give you 2 similar triangles here. They have the same corresponding angles, but unless we know one length, we don't know how big the triangle is. So angle, angle, angle cannot be solved. We have to have a length to start with. Final case, and I put it at the end because it's a bit of a pain. It is the side, side, angle. Be careful, it's not the angle, side, side. Although these can be a bit of a pain in the angle, side, side. So we'll watch these carefully. Let's see what happens with these. This is when we have an angle, a side, and then we have the side that goes with that angle. So let's see what can happen here. Problems. If we have an angle that is too big or a leg that's too short, we end up with something that looks like a fishing pole. That A leg is just dangling there from B. B is too tall. A is not going to hit the ground. There's not a triangle. The other possible problem we can run into is on these 2 triangles on the right, I've got the exact same angle A, I've got the exact same side B, I've got the exact same side A, but you see the angle B could be acute like it is in the top, or it could be obtuse like it is in the bottom. So we need to figure out how to tell whether or not there's a triangle and whether it's acute or obtuse. Actually, when we solve these, we'll just have to give both possibilities. So how do we tell? Quickly, there are side-side angles. This is all the ways that you could be given 3 letters, A, B, and C. I'm using A, B, and C generically. So for my examples, I'm saying A, little b, capital A. In essence, what I'm going to be referring to is little a and capital A go together. So you'll hear me refer to them that way. And then B is the side that's between them. So if A is bigger than or equal to B, in other words, if the side going with the angle is larger or equal to the other side that we're given, there will be exactly one triangle, and that is the nice case. So that's a wonderful case. In order to figure out the other cases, we're going to look at the altitude of this hopefully triangle. So we let h be the altitude to the top angle, and in this case h would be b sine A, just like we saw earlier. Now if A is smaller than this altitude, then there's no triangle because it's like the fishing pole. It's just dangling there. A will not touch the ground, so we can't complete the triangle. So if A is less than our altitude, no triangle. If A is bigger than our other side, one triangle. Third case. If A is between those two, okay, A isn't too short, it's not too long, it's not longer than B, giving us one triangle, it's not shorter than H, giving us no triangles, it's between H and B. Then that gives us two possible triangles. One of them, which when we solve, it will give us an acute angle for B, because that's the way our calculator works. When we do the inverse sine function, it'll give us an acute angle. So to find those two triangles, we'll first solve it, and it'll give us an acute angle. And then what we're going to do is find the supplement of B. And remember, I said earlier, the supplements have the same value for sine. So if we end up needing to take the inverse sine of 0.3, well, whatever two angles are going to give me that value, the two supplements. So the calculator is only going to give me one of them. We need to figure out the other one. So what we'll do is subtract the B that we calculate from 180 to find the supplement. And we're going to call it B prime. Notice that our angle A and angle A prime, they're actually the same. Side B and side B prime are actually the same. And side A and side A prime are the same. It's just that starting with angle B, we end up with different values. This is also going to change the values for angle C. Notice on the left side it looks kind of rightish, maybe a little bit more. On the right side, that's on the left side, on the right side it's a tiny acute angle. On the left side, side C, which is going to go from angle A to angle B at the bottom, it's pretty big. On the right side, it's probably the smallest of the three sides. So it's going to totally change our triangle other than the three things that are given. Alright, let's stop here and we will work on some practice.